Welcome to a lab tour of Soiltest Farm Consultants. We are an employee-owned company that has been operating in Moses Lake, Washington since 1976. Our lab offers a wide range of analytical services for farmers, fertilizer dealers, food processors, and composters. These services are performed by the most qualified staff of professionals in the Northwest, using the most up-to-date technology in the industry. Currently, our employees have an average of 18 years of experience. Soiltest Farm Consultants has experience in several different types of analysis. We offer testing for soils, plant tissues, feeds such as alfalfa or Timothy hay, water, compost and manure or fertilizer products. We hold certifications from several entities for each type of analysis. Now, let's look inside the lab. We will show you the entire process for a typical soil sample from receiving to reporting. This is our sample receiving area. On a busy day, we will process several hundred samples. Samples come in directly from consultants and individuals or can be sent in by mail, UPS, or FedEx. Each sample or group of samples should have accompanying paperwork. The information from the paperwork, such as the name of the client, grower, field ID, depth of sample, what crop is to be grown, and what testing is needed, is all entered into the computer. The sample is given a lab number that is referenced within the lab. Once all the samples for the day have been entered into the computer, a bench sheet used in the lab is produced for each test. Before the samples are to be analyzed, they must be dried and ground. The samples are placed into aluminum trays and dried overnight at 40 degrees Celsius in large ovens with plenty of air movement. Other materials such as plant tissue are dried at slightly higher temperatures. Once the soil samples have dried, they go through a grinder and a sieve that break up soil clods and remove any material that is greater than 2 millimeters. The actual lab analysis of soil uses the portion less than 2 millimeters. Separate grinders are used for plant tissue, feeds, manures, and compost samples. Grinding the sample allows for thorough mixing and homogenization of the product. Once ground, the bench sheets direct the lab crew to know which sample needs what testing. Further, the bench sheet gives the tray number and the location on the tray into which to weigh the sample. Rows within trays are identified by colors and includes 10 samples followed by a reference sample. This means that every 11th sample is a known and assures quality control within the laboratory. After weighing a specific amount of soil into the cups of the trays, soil nutrients are extracted with liquid solution. This dispenser is connected to a solution and adds equal amounts of liquid to each cup in the tray. For example, one phosphorus extraction method uses sodium bicarbonate solution, better known as baking soda, as an extractant. The trays are then placed on a stirring machine that mixes each sample for a set amount of time. The mixers are attached to a wash and drain system to eliminate carryover from subsequent tests. Plant tissue samples are digested with a mixture of two strong acids, nitric and perchloric acid, in this fume hood. The samples and liquids are boiled on a hot plate until all of the organic compounds are broken down into elemental forms. After mixing, an entire row of sample is poured through filter paper into a corresponding filtrate tray. On a busy day, we will use several thousand filter papers that are individually hand-folded. The analysis is performed on the filtered liquid. All the trays used have to be washed. This washer cleans one tray row. One side washes with hot tap water and the other is a rinse with deionized water. Washing trays is important because contamination of subsequent samples is unacceptable. This machine is our pH and electrical conductivity meter. It can measure 3 samples for pH and 3 samples for EC simultaneously. The computer program is attached to our Lab Information Management System, or LIMS, so there is no handwriting of data. This instrument is a recent significant improvement over when this analysis was done one sample at a time. One of the methods of analysis that we frequently utilize is colorimetry. Basically, when a sample is mixed with certain reagents or chemicals, the sample will turn a certain color. The intensity of that color is directly proportional to the concentration of the nutrient for which we are testing. In other words, the darker the color development, the higher the nutrient concentration. The samples are passed through a flow cell that shines light through the sample in order to measure color intensity. The machine is calibrated against samples of known concentrations. This instrument functions on the same principle of colorimetry and only differs from the last picture in that the machine adds and mixes the reagents automatically. In this configuration, we are able to analyze for nitrate and ammonium simultaneously. For elemental analysis, we use an instrument called an ICP, which stands for Inductively Coupled Plasma Spectrophotometer. The sample is pulled from the test tubes and mixed with argon gas. A plasma flame is ignited and the sample passes through a torch head. As the elements heat, they become excited and give off a certain wavelength of light. Those wavelengths can be separated and compared against known intensities. The beauty of this instrument is that it can measure several elements such as phosphorus, potassium, calcium, magnesium, sodium, sulfur, boron, zinc, manganese, copper, and iron in a plant tissue sample at the same time in about 20 seconds. All of these instruments are tied to our LIMS system so that data entry errors are eliminated. Feed analysis has become an important part of the services we offer. Ground samples are placed in a glass-faced analysis cup. The sample cup is loaded onto an NIRS machine. A beam of near-infrared light is bounced off the sample, which is calibrated against hundreds or thousands of known samples. We are able to measure crude protein, fibers, and some mineral nutrients rapidly. Some materials do not lend themselves to NIR analysis, and for these we are able to utilize wet chemistry methods to determine protein, minerals, and fibers. For analysis of total nitrogen in all sample matrices, we have a LICO CN628. This instrument measures total nitrogen and total carbon at the same time. Samples are weighed on an analytical balance into small foil capsules. The capsules are loaded into carousel, which drops the samples into a furnace on the machine. The sample is burned and the gases that are produced are analyzed for total nitrogen and carbon. All of this work and the resulting data are relayed into the computer system. Finally, the LIMS generates a report that shows pH, salts, organic matter, and all of the major and minor nutrients. If a crop and yield goal are listed, we can include an interpretation and fertilizer recommendation for the sample. Reports are reviewed by professional staff members prior to being sent out to the customers. The fertilizer recommendations are based primarily on fertilizer guides that were developed by Washington and Oregon State Universities, as well as the University of Idaho. Since many of the university fertilizer guides are aged, we have included our own experience in the fertilizer recommendations that we have acquired over more than 40 years of testing in the agricultural industry. Thank you for your interest in seeing inside the operations of Soiltest Farm Consultants. If you ever would like to stop in and see the operation for yourself, please feel free to do so. We have done a great job of keeping our instrumentation up to date to provide you with the most accurate and precise data possible.